So this is video number 3 in our series, and we're now looking at the pressure law, or Gay-Lussac's law. And again, it's our further analysis of looking at what happens to gas when we alter one of these 3 variables, and we know what they are by now if you have watched the previous 2 videos, one being pressure, the other being volume, and the next is temperature. So for Gay-Lussac's law, and of course if you don't get the fundamentals here, then please feel free to watch the other videos and build up to this one. So for Gay-Lussac's law, what we have is that pressure is directly proportional to temperature. And what that is that the pressure of a fixed mass of gas, so we're not changing the mass, it's directly proportional to its thermodynamic temperature at a constant volume. So therefore, if we increase, so let's say we're right here on our graph and we move to here, both pressure and temperature would be increased. So perhaps a good example of this, just think of your pressure cooker, where you add your water and whatever you're adding to the pot, and as soon as you increase the heat, turn on the stove, then you see where the pressure starts to increase massively, and that is also proportional to the heat that you've added in terms of the rate at which the pressure is increased by and how much the pressure is increased to. So let's say we have some T1 value of 290 Kelvin, and that all of a sudden changed to some amount that we're told to be 397 Kelvin. Now our initial pressure P1 was 150, let's say 150 kilopascals, and we need to find out what P2 is going to be. So in this case, once again, it's just a matter of using the formulas that we have correctly. So if we input our value for P1, then we have that as 150. We don't need to convert the kilopascals because it's going to be the same units. And our T1 here, 290, that will be equal to our unknown, which is P2. And we know what T2 is, that's 397. So therefore, if we want to find out our P2, we can do it 2 ways. We can work out what this will give us, or we can just do it in one go, where we say 150 multiplied by 397 and then divide all of that by 290, and that will give us a final pressure of 205.3 kilopascal. So that's our final pressure there. Now the only other thing I would like to definitely point out is, let's say we need to find either T2 or T1, because that's where a lot of times issues come from, where to rearrange the formula to get those values in the denominator, it tends to be problematic for some people. So you can just write this down. So if we're finding T2, then T2 is going to be equal to our P2 times by T1 and divided by P1. And if we're finding our T1, then it's kind of very similar, but it's instead P1 multiplied by T2 and then all divided by P2. So it's just to swap them around really. So I hope you found this useful. Let me know if you'd like me to continue this series, because if you do, then we can next look at Dalton's law of partial pressure, but I'm not going to do that video until you indicate that you'd like to see that one. So please let me know in the comments.